second. Okay, so during our first meeting, we already discussed information capacity, which is also measured in terms of bit per second. Okay, so when we're dealing with the number of bits transmitted per second, we're dealing with bit rate. Okay, second is the baud rate. So baud rate is the number of symbols per second. Okay, if you encountered number of signaling elements, number of symbols, number of states, or number of conditions per second, so you're also dealing with baud rate. Okay. So to be able to compute for the capacity in bits per second, we're going to use the formula S log to the base 2 M. Okay? Looks familiar. Okay? So instead of using B, so we're going to use S. Okay? So for you not to be confused, kasi di ba ginamit natin yung B for bandwidth. So this S is represented by baud rate. Okay? So baud rate, again, is symbols per second, signaling element per second, state per second, okay? And M is the number of possible states per symbol, okay? So direct mamaya may mga problem solving tayo. Okay, so baud rate or baud, so that is 1 over the time of one signaling element, okay? So baud is the symbol rate, baud per second, or symbols per second, or signaling element per second, okay? Then TS or T sub S is the time of one signaling element, okay? So in FSK and ASK, they are and PSK, so there are methods or ways for you on how to identify easily what baud or what baud rate is being identified. So mamaya i-discuss natin kung paano malalaman ang baud rate, input bit rate ng ASK and FSK. So next week yung PSK. Okay? So for you, next week pala, ay ano na natin, no? Midterm exam. So that is 9 to 13. So next week, I am going to discuss computations, additional computations about FSK, and introduction to PSK and computation about PSK. And that would be the last topic for your prelim examination, okay? PSK. From block diagram of digital communication system up to PSK or phase shift keying, okay? So exam type would be objective and computation. Okay? Next. So example problem. So a modulator transmits a modulator transmits symbols, each of which has 64 different possible states, 10,000 times per second. Calculate the baud rate and the bit rate. Okay? So again, a baud rate is the symbols per second times per second or the signaling element per second. Okay? Ay, susulat ko pala. Annotate. True. Okay? So you're asked to compute for the baud rate. Yung A is the baud rate. Okay? So baud rate is just equal to 10,000 baud, or in scientific notation, so this is 10 kilobaud. Okay? So baud is named after J.M.E. Baudot. Okay? Then the bit rate. Okay? To be able to find the bit rate, what you're going to do is to find the information capacity or capacity. So capacity is equal to S log 2 M. Okay? So S, na-compute na natin, which is the baud rate. That is 10 kilobaud, which is 10 times 10 raised to 3. log 2, ang M, that is possible states, which is 64, which is equal to what? Compute. Pindot.
60,000 po, sir.
60,000
po.
Okay, so that is 60,000 or equal to 60 kilobit per second. Okay? Again, the unit of bit rate is kilobit per second. Okay? Okay. Clear ko na. Okay. So ito yung binabanggit ko kanina na signaling element. Okay? So when we're talking about signaling element, it also deals with symbol. Okay? It is also known as symbol or state or signaling element and could be included as change in the amplitude, frequency, or phase. Okay? So pag na-encounter nyo yung word na signaling element per second, so you are also dealing with baud rate. Okay? Next. Yun. Okay. So during your quiz, I asked you to find or to define the definition of bandwidth. Okay. Some of you were able to define the definition or the basic definition of a bandwidth. Okay. Okay. The basic definition of bandwidth is it is the difference between the maximum and the minimum frequency. Okay. So when we're dealing with bandwidth, we're dealing with frequency. So yung iba, binigyan ko ng points pag nasabi mo yung unit ng frequency, which is hertz. Okay? Okay. So in digital communication, we are dealing with ideal Nyquist bandwidth and Nyquist bandwidth. Okay? First is the ideal Nyquist bandwidth. How can we say that we're dealing with or we're going to use an ideal Nyquist bandwidth? Okay, so we are dealing with noiseless transmission. The keyword is noiseless. Okay, if you are going if you are using a noiseless transmission medium, okay, so to be able to find the bandwidth, so that is bandwidth is equal to input bit rate over 2. Okay? FB. So, may encounter nyo ng ang input bit rate in different times of digital modulation. You can encounter that on ASK, FSK, and PSK. And those digital modulation techniques has different value for input bit rate. Okay? Okay. So when asked to find the input bit rate, so that is just twice the bandwidth. Okay, provided that is given in the question na you are using a noiseless transmission medium. Okay, huwag kakalimutan. Noiseless. Okay. Next. Kapag hindi nabanggit na it's noiseless, okay, so we're just using Nyquist bandwidth. And in default, so pag hindi siya nabanggit, so we're going to use the Nyquist bandwidth, not the ideal Nyquist bandwidth, but the Nyquist bandwidth only. Okay, so to be able to find that, what you're going to do is to divide the input bit rate, FB, by the number of input bits. Alright? So, yun yung pinakaiba nila ha. Don't forget. Okay. So, itong PowerPoint presentation naman na ito ay ipapasa ko naman sa inyo. Mamaya. Or tomorrow. Okay. So, si MR encoding naman, in digital communications, you will encounter the word MRE, which is a term derived from the word binary. Okay, so M simply represents a digit that corresponds to the number of conditions, levels, or combinations possible for a given number of binary variables. Okay, so meron tayong formula to be able to find the number of conditions or levels that is possible for a given number of binary variables. So para makuha yon, so we have n is equal to log 2m. Okay? So kanina, kapag kapag you are asked to find the bandwidth of Nyquist bandwidth, so that is FB over N. Okay? So that N can be computed using the M-Airy formula, which is N log 2M. So pwede natin sabihin na bandwidth is equal to input bit rate over log 2M. Right? So M is the number of bits necessary. Okay, kapag halimbawa, given na yung N, for example, compute for the bandwidth given an input bit rate of 25 kilobits per second and number of bits equal to 64. So makukuha mo na yung bandwidth agad-agad. But if you are given a problem saying that you need to compute a bandwidth given an input bit rate of 25 kilobits per second and number of conditions which is equal to 64, gagamitan mo pa siya ng log. So ang magiging sagot doon is bandwidth is equal to FB over log 2 64. Ang bandwidth ay 25 kilobits per second. Okay? So ang unit ng bandwidth, don't forget, that is hertz. Okay? So computing nyo lang. Ganyan. Okay? Pag malilito. Clear ko lang. Hindi nakiklear. E di wag. E di don't. Ayan. So papasok na tayo sa different digital modulation techniques. Okay? There are the most common of the digital modulation techniques are the amplitude shift keying, the frequency shift keying, and the phase shift keying. Okay? So, can someone share kung ano yung natutunan nila about amplitude shift keying? Anyone? Based on sa assignment nyo, what you have understood or remembered about ASK?
Ako po, sir.
Ay, ikaw. Sige, hali. Open cam para makita kanila.
Doon po sa
Open cam.
wait lang po. Doon po sa amplitude shift keying, where yung
Nakita niyo na ba siya? Ba't
ang
hindi ko siya
input
nakikita?
natin ay mababa, ang ibabalik niya pong output ay 0, wherein po yung mataas na input, siya po as is po siyang ibabalik as output.
Hindi kita nakita. Nag-open cam ka ba?
Po ba?
Ayan. Okay. Ano sabi mo?
Doon po sa ASK po, pag po yung high input po niya, ibabalik po siya as is po as output, wherein po yung pinakamababa po na input, siya po is ibabalik as 0.
Huh?
Yun po yung nakita kong definition eh.
Okay, sige. Other? Wala kayong naiintindihan sa assignment nyo? Grabe naman kayo. Sige, magtatawag ako yung may pinakamagandang smile sa profile picture. O ikaw, Fernando, dahil ikaw ay parang tatakbo diyang SK sa iyong picture. Anong naaalala mo? Anything that you can remember?
Surveys on the study ko po about sa amplitude shift keying is
Aray, basics
ako po
na
ay
yung study. Okay.
isa po siyang technique to convert our analog signal to
Mali.
digital signal and
Baliktad. Digital to analog.
digital to analog po, and also yun rin po ay nasabi po nila Idaros is ang naintindihan ko rin po is yung sa binary sequence po na ginagamitan ng mga voltage po. Tas, yung pinaka high peak po niya, yung pinaka high voltage, tas 1, then yung pinaka low po is 0. Yun na po, sir.
Okay, thank you. Okay, last. Katapat. Is it katapat? Katapat, how do you pronounce your surname?
Katapat po, sir.
Katapat, okay. Anong naalala mo? Anything that you can remember?
Sir, yung nadagdag lang po sa definition na nakakuha ko po ay yung ano po, yung amplitude shift keying po ay also known as DAM, digital amplitude modulation po. Tapos OOK po, yung on-off keying or continuous wave. Ayun po, sir.
Okay, very good. Okay, so when we're talking, tama na. So when we're dealing with amplitude shifting, some of the books ay tinatawag siyang digital amplitude modulation, DAM, on and off keying. Why? Because of the low state. I mean, two states. First of which is the high state, which is in voltage 1 or logic 1, which is equal to 1 volts. Okay? Or low state, which is equal to logic 0, which is equal to negative 1 volts. Okay? So continuous wave then. Why? Because it is a method or digital method wherein the digital signal is being converted into an analog signal. Okay? So that is meant by continuous. Okay? Tuloy-tuloy. And high state, so kaya tinawag na on and off keying because of high state, which is also called as the 100% carrier amplitude. Okay? Nasaan ba yung... May ano ba ako? Nasa PowerPoint ka ba yun? Sige, para mas makita nyo. Ayan. So, sabi, it is also known as DAM, on and off keying. And amplitude shift keying is the simplest modulation technique wherein a binary information signal directly modulates the amplitude of an analog carrier. Okay? So again, when we're dealing with amplitude shift keying, so a modulation technique, okay? So modulation, din pinadefine ko din sa inyo. So again, the very basic definition of modulation is a technique or a process wherein a property or some of the properties of a waveform is being is being varied, okay? Binabago mo yung property, okay, of a carrier waveform. Okay? So in the case of amplitude shift keying, the property being varied is the amplitude. Okay? Okay, so the amplitude of the carrier signal varies with respect to the amplitude of the message signal. Okay? So tinatawag din siyang, may tinatawag tayong binary amplitude shift keying or BASC. Why? Because it deals with the 0 state and the 1 state. Okay? So yung 1 state, tinatawag din siyang 100% amplitude. Kapag naman 0 state ay lower amplitude. Okay? Kapag 100% amplitude, the output is the carrier signal. Kapag lower amplitude, there is no output at all. Okay? So kung titingnan niyo yung example natin, so again, sabi ko kanina, this is a modulation technique wherein the binary signal, okay? The binary signal is being converted into an analog signal. As you can see, these are binary inputs, okay? In terms of binary sequence, okay? Then the output is analog, which is continuous, okay? So ito yung meant by continuous. Kaya siya itinawag na continuous wave, okay? Nagigets po ba?
Yes po, sir.
Okay.
Yes po, sir.
So, any question? So, baka may tanong kayo. Okay, wala na? Okay, moving on. Okay, so some of the books, it's just simply represented by this one. Okay, ganyan lang kasimple. Okay? So, automatic, kung nakikita nyo yung DAM output or the digital amplitude modulation output, kapag 0, wala siya talagang output signal. Okay? Flat lang. Okay. Ayun. So in amplitude shift keying, we have a general expression or the general equation which is V ASK of t is equal to 1 plus Vm of t multiplied by A over 2 cosine omega c t. Okay? So isa-isahin natin. So VAS or the voltage amplitude shift keying voltage wave is equal daw kay 1 plus VMT. So VMT, that is binary input, which is the binary input, we're dealing with the modulating signal, which is in terms of volts. Okay? So yung A over 2, so that is the unmodulated carrier amplitude. Again, that is in volts. So omega C or equal to 2 pi FC T. F is the carrier frequency. So that is the analog carrier angular frequency, which is equal to rad per second. Okay, so pakita ko lang sa inyo kung what will be the output. Okay, so again, sabi nyo kanina, we only have two outputs. One is the logic 1 and the logic 0. So when we're dealing with logic 1, we're dealing with 1 volt. And with logic 0, we're dealing with negative 1 volt. Okay? So, solve natin. Pakita lang natin. Okay. Sabi, V ASKT is equal to 1 plus VMT multiplied by A over 2 cosine omega ct. Okay? For logic 1, we're dealing with 1 volt, which is, this is the value of the VMT. So, equivalent pala niya ay 1 plus 1 A over 2. Ay, wait lang, may kumakatok. Okay? So this will be equal to A sub 2 cosine, ay, may cosine na pala, cosine omega ct. Okay? So this will be equal to 2, this will be cancelled out. So when logic 0, the voltage ASK of t is just equal to A cosine omega ct. Okay? That is for logic 1. Right? So when we're dealing with logic 0, which is equal to negative 1 volts, so this will be just be equal to 1 minus 1. So basically, this is a 0. Automatic, kasi 0 multiplied by this one is 0. Okay? So again, we only have two outputs for binary ASK, which is A cosine omega ct or 0. Okay? Nagets? Nagets
Yes,
po ba?
Yes po.
Yes, sir.
Okay. Thank you. Okay, I'm gonna clear all this. So moving on. Ayun. So amplitude shift keying. Okay? So in amplitude shift keying, again, as what I've mentioned a while ago, we're dealing with bandwidth and the baud rate. Okay? So ASK bandwidth, to be able to find the ASK bandwidth, you need to find the input bit rate. Okay? So if you are asked, what is the bandwidth of an ASK transmission given an input bit rate of 25 kilobit per second, so that is also equal to the bandwidth. Okay? And when you are asked to find the baud rate or the baud, so that is also equal to the input bit rate. For example, if the bit rate for an ASK signal is 400 bits per second, the baud rate is, so basically the baud rate is 400. Okay, so halimbawa hinahanap yung bandwidth. So bandwidth is equal to 400 hertz. FB is equal to 400 BPS. And the baud rate is equal to 400 baud. Okay? Gets? Gets?
Yes po.
Okay. Okay, next. Next. Determine the baud and minimum bandwidth necessary to pass a 10 kilobits per second binary signal using amplitude shift keying. Okay? So basically, when we're dealing with baud, so that is 10 kilobaud and the bandwidth is equal to 10 kilohertz. Right? Yun. So after that, we're going to deal with frequency shift keying. Okay? So property being varied is the amplitude. Okay? So in the case of frequency shift keying, ang binabago naman ay frequency. Okay? So frequency shift keying is a form of constant amplitude angle modulation similar to standard frequency modulation. Okay? So actually, during our principle of communications, so that is ECE 1, in our case, sa mga electronics engineering student, we have principle of communication first before taking the digital communications. Okay? Sa case nyo kasi, nag-digital agad. Wala kayong analog. Okay? So yung frequency shift keying ay katulad din halos ng frequency modulation. So paano? Paano in a sense na frequency is being modulated. Okay? When the baseband signal modulates the frequency of the carrier signal, the process is called frequency modulation. For digital baseband signal, it is called frequency shift keying. Okay? Tingnan natin. Okay? So kung nakikita nyo dun sa diagram, we have carrier signal 1 for binary 1. Ito yan. Okay? So carrier signal 2 for binary 0. Basically, that is logic 0 and logic 1. Okay? So this is the sinusoidal wave. Okay? In terms of time. Okay? Yung baseband message signal ay in terms of, these are analog signal, this is digital signal, and this is your modulated signal. Okay? So napansin nyo, mas compressed kapag logic 1. Ito siya. Okay? Pag logic 0, ganito yung output niya. So napansin nyo, meron din tayong FM and FS. So what is the difference between FS and FM? Okay? Makinig. So, ganito lang din siya. Mamaya pala yun. Okay? So, ito muna. Mamaya ko i-discuss kung ano yung Fs and Fm. So, magagamit nyo siya sa formula eh. So, ito na lang muna. Okay. So, in frequency, in ASK, we have the general expression and our general equation. So, in FSK, we also have a general expression or general equation. So, that is f of V f of SK of t is equal to VC cosine 2 pi FC plus VMT change delta F times T. Okay? So isa-isahin natin. Yung VFSK is the binary FSK waveform that is in volts. Nakalimutan ko lang. That is volts. Bilagyan natin. VC, which is napiyok-piyok pa. VC is the peak analog carry amplitude. Again, that is in unit volts. FC is the analog carrier center frequency. Again, that is frequency. So that is in hertz. Change in F or the peak shift or the peak frequency deviation is the is the difference between your frequency FM and FS. So VMT is the binary input modulating signal again, which is in volts. Okay, so to be able to compute for the output of logic 0 and logic 1, so sige, compute natin. Stop share. Okay, so ating general expression for FSK is V FSKT is equal to VC cosine 2 pi FC plus VMT change ng F T. Okay. So remember, when we're dealing with logic 1, so that is with the amplitude of 1 volt. Right? So this will be just be equal to VC cosine 2 pi FC plus, dahil ito ay 1, so this will be equal to delta F or the frequency shift deviation. Okay? For logic 0, which is negative 1 volts, so this will be, instead of this being positive 1, this will be equal to negative 1. So this will be just be equal to VC cosine 2 pi FC minus frequency shift deviation or delta F T. Okay? No. As remember, as you can see in the general expression of FSK, so we're dealing with peak frequency deviation, which is directly proportional to the binary modulating signal voltage. Okay, so by definition, when we're dealing with directly proportional, so that the increase in peak frequency deviation is also an increase in VMT. Okay, the decrease in peak frequency deviation is also a decrease in VMT. Okay, nakuha? Gets po ba?
Gets po.
Okay. Thank you. Okay. So in frequency shifting, you can see in the diagram, so we're dealing with FS and FM. As you can notice, FS ay katapat frequency. Remember, FS or space frequency is represented by logic 0. Okay? So when we're dealing with logic 0, that is called a space frequency. Okay? And when we're dealing with logic 1, FM. Okay? And the separation between them is called peak frequency deviation, which is equal to the summation of these two. So that is 2 delta F. Okay? Without taking into consideration of the negative sign of the peak frequency deviation, because we all know that there is no negative frequency. Okay? So, tanggalin mo lang si negative. So, basically, parang kukunin mo lang yung anong tawag doon? Dimension. Okay? Ang dimension niya halimbawa ay 1 Hz. Okay? So, mamaya makikita nyo kung ano bang gamit ng FM at ni FS. Next. Yon. So, frequency shifting. So, there is a frequency deviation. So, that is equal to the absolute value. Remember, it should be an absolute value. Okay? So, because we don't have negative value for frequency, so that is the absolute value of the difference of the mark frequency. Again, mark frequency is designated by logic 1, and space frequency or FS is designated by logic 0. The absolute value on peak frequency deviation. Okay? So ito lang, example lang to. So again, we have a binary input of binary signals in binary sequence. So that is 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. Okay? So the analog output, again, deals with the FS and FM. Okay? So dito, pinapakita lang na kapag space, binary input niya ay 0. Kapag mark, so that is 1. Okay? Yon. So in ASK, we have bit rate, baud rate, and bandwidth. Okay? In FSK, we also have bit rate, baud, and bandwidth. Okay? So to be able to find the bandwidth, okay? To be able to find the bandwidth of FSK, we have the formula of the absolute value of the difference of space frequency minus input bit rate minus the mark frequency minus the input bit rate, which is just equal to the WB. So kanina nakita natin sa formula na ito ay equal kay 2 delta F. FS minus FM over 2. Ito lang yon. I-multiply mo doon. Okay? Kaya naging 2 delta F plus 2 FB. So, i-factor lang natin. Kaya naging bandwidth is equal to 2 delta F plus FB. Okay? So, ang baud rate po nito, ang baud rate ng FSK ay equal din kay input bit rate. Okay? O, sample tayo. Determine A, the peak frequency deviation, minimum bandwidth, the baud for a binary FSK signal with a mark frequency of 49 kHz and space frequency of 51 kHz and an input bit rate of 2 kilobits per second. Okay. So again, you are asked to compute for the peak frequency deviation, which is delta F is equal to the absolute value of Fs minus Fm over 2. So substitute lang natin yung value. So that is 49 kilohertz. Kapag nag-compute, don't forget to put formula ha. Minus 51 kilohertz over 2.
Sir, choppy
So
po
this is
kayo.
absolute value over 2. This is equal to 1 kilohertz. B. For the minimum bandwidth. So bandwidth is 2 delta F plus 8 bit rate.
Sir, choppy po kayo.
Hello, hello.
Hello.
Alsaga, ikaw na magturo.
Shout out. Jump Michael.
Hello? Okay na?
Okay na ba?
Yes po, sir. Okay na.
Saan tayo nawala, mga Beshuwap?
Doon po sa first example, letter A
Okay.
po.
Okay. So again, again, you're asked to find the peak frequency deviation. Okay, so when we're dealing with peak frequency deviation, we have the formula of the absolute value of Fs minus Fm over 2. Okay, so given naman po yung space frequency at mark frequency. Okay, so halimbawa, sinabi kong with a logic 1 frequency, alam nyo kung ano yung Fs at Fm. Okay? So sa case na to, that is equal to 1 kilohertz. Okay? So 49 must equal to 1 kilohertz. Okay. So for number 2, you're asked to find the value of the minimum bandwidth. Okay? So when we're talking about minimum bandwidth, we have the formula 2 multiplied by the peak frequency deviation plus input bit rate. Okay? We already know what is the value of the peak frequency deviation. So that is 2 multiplied by 1 kilohertz. B is input bit rate, which is given by 2 kilobits per second. Okay, so 2 kilobits per second. So this is just equal to 2 plus 1, that is 3, 6. So 6 kilohertz. Okay. And lastly, you are asked to find the baud. Okay. So when we're dealing with FSK, the baud is just equal to the bit rate. So baud value is equal to 6 kilobaud. Okay. Nagets po ba? Hello.
Yes.
Okay. Okay. Thank you so much. Next problem. So a rectangular pulse polar baseband signal is used to modulate an RF carrier in FSK. If the baseband signal has a data rate of 200 kilobit per second and the two RFCs are 150 kilohertz apart, determine the bandwidth. Okay? So again, we need to write the formula. Bandwidth is equal to 2 delta F plus FB. Okay, so kayong malilito. So we have two RF frequencies which are 150 kilohertz apart. So kanina, sa drawing natin, so this is your FC, so this is your FS, and this is your FM. Okay? So basically, this is 150 kilohertz. Okay? So dahil yan ay 150 kilohertz, so ang iyong 2 delta F daw ay equal kay 150 kilohertz. Okay? So pwede natin siyang i-distribute. So this bandwidth is equal to 2 delta F plus 2 FB. Okay? Next. So ang sabi baseband signal, okay? So hindi siya sinabing input bit rate. Okay? Again, kapag ideal ang gagamitin at hindi sinabing noiseless, gagamit po tayo ng formula na bandwidth is equal to FB over N. Ano nga pong solution dito? Wait nga. Balikan natin. Ayun. Ideal. FB over 2. So in wala akong calcium. Wait lang ako, wala akong ng calcium. Ay, balikan ko na lang. Balikan ko pala to. Kasi parang may impact ata kapag rectangular pulse polar. So balikan ko to. Okay? So next meeting, solve natin to. Okay? Para maliyat yung solution ko sa kabila. Okay? So hindi ko na ituro yung rectangular pulse polar. Anyway, next problem muna tayo. Ayun. So next problem, okay. In binary frequency shift keying, the given signal waveforms are u sub 0t is equal to 5 cosine 20,000 pi t, where t is greater than or equal to t, greater than or equal to 0 but less than t. And u sub 1t is equal to 5 cosine 22,000 pi t. Wherein t is again greater than or equal to 0 but less than t. Where t is the bit duration interval and t is in seconds. Both u sub 0 of t and u sub 1 of t are 0 outside the interval t is greater than or equal to 0 but less than or equal to t. With a matched filter correlator based receiver, the smallest positive value of t in milliseconds required to have u sub 0 of t and u of 1 of t uncorrelated is. Wala, ano daw yun? Wala, isolve natin. So, isusulat natin yung given. We have our given u sub 0 of t is equal to 5 cosine 20,000 pi t, where t is greater than or equal to 0 but less than or equal to t, and u sub 1 of t is equal to ano daw? 5 cosine 22,000 pi t yan. So have two given signals. Cosine signals, cosine wave signals. Okay? So ang tanong, paano daw sila ano daw value ng t para maging equal to 0? Okay? So dahil sila uncorrelated, if two signals are uncorrelated, we have the formula integral of 0 to t u sub 0 of t multiplied by u sub 1 of t is equal to 0. Okay, remember, when two signals are uncorrelated, we need to use the formula integral of 0 to t and the product of u sub 0 of t and u sub 1 of t is equal to 0. Okay, so palitan natin. So this will be equal to the integral of 0 to t. U sub 1 is 5 cosine 20,000 pi t multiplied by 5 cosine 22,000 pi t. I forgot dt. dt is equal to 0. Okay? As you can see, there is a product of cosine of two different angles. So dapat alam nyo yung cosine identity for that. So kailangan nyo itong i-memorize. Cosine A times cosine B is equal to baba ko na ito. Taas ko ilalagay. Cosine A times cosine B is equal to cosine A plus B plus cosine A minus B over 2. Okay, then sine A times sine B is equal to cosine A minus B minus cosine A plus B over 2. Sine A times cosine B is equal to sine A plus B plus sine A minus B over 2. And lastly, cosine A times sine B is equal to sine A plus B minus sine A minus B over 2. Okay? Yun. So, kailangan nyo i-memorize yung different trigonometric identities. Okay? So after that, so nakita nyo, 5 and 5 can be multiplied. So that is the integral of 0 to t, 25. Then apply na natin yung trigonometric identity. So cosine, so that is 20,000 divided 22, plus 22,000 is just 42,000 pi t. Plus cosine, so cos 20,000 minus 22,000 is equal to negative 2,000 t or equal sa what? 2,000 pi t. Okay? So magtataka kayo, oh, bakit sir positive? Akala ko ba negative? So we have again a trigonometric identity that cosine of negative a is just equal to cosine a. So kung pipindutin nyo po sa calcu, cosine, halimbawa, pindutin sa calcu, cosine negative 90 is just equal to cosine 90. Okay? So kapag sine, so halimbawa, sine of negative a is equal to negative sine a. So kung pipindutin po natin sa calcu, so that is sine negative 90 is just equal to negative sine t negative sine 90. Okay? Okay. So, don't forget 2. Okay? So, pwede nating ilabas yung constant. Again, so when we're dealing with constant in integration, what we do is that we put the constant outside the integrating factor or the integrating symbol. So, this will be equal to 25 over 2 integral of 0 to t cosine 42,000 pi t plus cosine 2,000 pi t dt is equal to 0. Okay? Nakakasabay pa? Hello?
Medyo po.
O ano na, nawawala na? Tutang na? Okay. So proceed tayo. So when we're dealing with integration of trigonometric identities, basically it includes angle. Okay? So papaalala ko lang kung paano mag-integrate. So for example, ito, integral ng cosine 42,000 pi t dt. So when we're dealing with integration of trigonometric identities with angle, what we do is let the value of the angle as u. So this is let u is equal to 42,000 pi t. And then find its derivative. So that is du is equal to 42,000 pi dt. Okay? So the integral of 42,000 pi t is 42,000 pi and the derivative of t is dt. Okay? So we need to find the value of dt. So divide both sides by 42,000 pi. Okay? So this will be cancelled out and the value of dt is just equal to du over 42,000 pi. Okay, so substitute natin. So this will be integral of cosine and ang value po ng 42 pi t ay u, diga? Ang value po ng dt natin ay du over 42,000 pi. Ay. Again, when we're dealing with constant, we put them outside the integrating factor. So this will be equal to 1 over 42,000 pi integral ng cosine u du. Okay? So anong integral ng cosine? So that is sine. So that is 1 over 42,000 pi sine u. Ang value po ng u natin ay 42,000 pi t. Yun. Okay? So ano lang ako, mag-clear lang ako. Erase lang ako nito. File save as 928.01. Okay? Okay. Erasure. Then draw. Okay? So, ang kasunod po nan ay, pinakita ko lang paano mag-integrate. So, that is 25 over 2. Okay? So, ang integral ng cosine 42 pi ay sine 42 pi t over 42,000 pi plus. Okay? So, same thing sa kabila. So, that is sine 2,000 pi t over 2,000 pi from limits 0 to t is equal to 0. Definite integral. Okay? So when we're dealing with definite integral, we have the upper and lower limits. Okay? If you can remember, we have two types of integral. Okay? So two basic types of integral. First of which is the indefinite integral. Okay? So when we're dealing with indefinite integral, it has the arbitrary constant, which is we're dealing with upper and lower limits, and the value of the integration is a finite value. Okay? So in dealing with upper and lower limits in integration, what we're going to do is to first substitute the value of the upper limit minus the limit of minus the value of the lower limit. Okay? So gawin natin 'yon. So isasubstitute natin yung lahat ng value ni t kay small t. So this is 25 over 2 sine ano nakakasabay pa 42,000 pi t over 42,000 pi plus sine 2,000 pi t over 2,000 pi. So basically, kapag isa-substitute natin dito ay 0, lahat yun ay 0 na. So yan na lang. Is equal to 0. And then, shift solve. T is equal to papindot po para masanay kayong pumindot. So your answer should be in milliseconds. Ano po sagot?
Wait lang po,
Wala.
sir.
Sige lang. Go, go, go. Hindi ko sasabihin yung sagot hanggat walang nagsasabi ng tamang sagot. Watch lang sagutin ko. Ano? Wala pa din?
Naglo-load din po yung calculator. Ito.
Loading, loading. Sige. Santayin natin. Ito pala. So, meron tayong final project. I wasn't able to tell sa last sa ano nga ba? GE. So, your final project will be isusulat nyo lahat ng tinuro ko in engineering lettering. So that is 30% of your final grade. Okay? So in engineering lettering, so i-discuss nyo yung mga isusulat nyo yung mga sinolve natin at mga sinulat natin. Ax in engineering lettering. So ang submission noon syempre a week before your final examination. Na-gets? Yung inyong final project? Yes, Trina,
Yes po.
what's your question?
Ay, good evening po, sir. Doon po kasi, sir, sa engineering lettering ay hindi po ba kami nagkaroon ng subject na nagdi-discuss po. Kaya hindi po namin masyadong alam po ba kung paano magsulat po ng ano. Ayun, so yun lang po yung aking ano, sir.
Basically, engineering lettering, maganda yung sulat.
Hindi naman po siya required na all caps or ano po.
Pwedeng nasa sa inyo, basta maganda yung sulat. Hindi siya waso-waso, as in, symmetrical.
Okay, thank you po, sir.
Sa examination nyo, magdala ko ng example. Oops. And kapag wala kayong final exam, wala kayong final project sa akin, tapos removal kayo, hindi kayo makapag-take ng removal. Ano na sagot? At saka yun ay magsisilbing reviewer nyo kapag kayo ay removal. Walang nagsagot. Walang pumindot. Wala. Walang sagot.
999.43 millisecond. Sir,
Mali.
sir.
O siya, hindi ko ibibigay ng tamang sagot. So, computin nyo. Isi-ship solve nyo lang. Malita. Okay. Okay. Pa-open cam ako para dun sa mga late. Pero wala na yung plus ha. Yung nag-open cam lang kanina. Di mo lamang kayo napindot. Grabe naman. Kaya sa exam, napansin ko nung last quiz nyo, most of you, hindi naman lahat, it's just pati pagpindot, mali. Yung kilo, mali. Yung mega, mali. Hindi alam yung ginagawa. Tamad kayong pumindot eh. Okay? So, hindi kayo papasa sa akin kung hindi kayo marunong pumindot ng calculator. Malabo kayong pumasa. Okay? So, kung sasanayan niyo yung sarili nyo na nakatingin lang habang nagdi-discuss ako, hindi ko alam. And sa DSP, mind you, DSP, Digital Signal Processing, kung itatanong nyo sa FOET yun, nagtitake ngayon, so that is computation. Sobrang computation niya in a sense na application siya ng advanced mathematics. Okay? So, when we're talking about advanced mathematics, wala kayong subject nun. Wala kayong advanced math. So, digital signal processing, combination siya ng integral calculus, differential calculus, differential equations. So, yon, sama-sama yung tatlong yon. Gagamitin mo sa isang problem. Ganun siya ka-complicated. So, kung sasanayan niyo yung sarili niyo na hindi nagsusulat or hindi man lamang nagko-compute, bala kayo. Anyway, game. Okay, 1, 2, 3, smile. Ay, wala. Ulit, sorry. 1, 2, 3, smile. Okay, smile. Save as. 9:20. 02. Ano? Lumabas na yung tamang sagot? Aray.
Hindi
Wala
pa po
pa
tapos
rin.
mag-load eh.
Tagal naman nun.
Kaya 56.41 milliseconds po.
Mali. Talaga, walang tumatama, pipindutin na lang. So, input mo lang yung kanina, tapos shift solve. Shift solve. Sa kabila, hindi ko din binigay kasi wala ating napindot. Bahala sila. So, aralin yung mga trigonometric identities na binigay ko, ha. Wala pa din. Ba't ang tagal? So, ang technique, okay? So, ang technique sa shift solve, ganito. So, matagal siya kasi nag-iterate siya. Iterate meaning nagsosolve siya based sa value na in-input mo kapag nag-shift solve ka. So, di ba? 2x plus x minus x squared is equal to 0. And nag-shift solve ka. Tapos, ang in-input mong value is 1,000. Naglagay ka ng 1,000. So, mag-iterate siya from 1,000 pababa hanggang lumapit siya sa tamang sagot. Okay? So, kapag nag-shift solve ka dyan and you are asked naman na milliseconds, so mag-input ka ng times 10 raised to negative 3. Okay? 10 raised to negative 3. Para yung sagot, kapag mag-iterate at magsosolve si calculator, malapit kay 10 raised to negative 3. O, dali. And your prelim exam pala ay Monday para alam nyo na agad. 34.99. Oh, mali. Baka naman kasi mali din ang pag-input nyo sa calcu. Naka-angle ha, that is sine, yung nasa loob is 42,000 pi x.
Negative 2.08 raised to 10. Ay, ano po pa? Ulit. Negative 2.08 times 10 raised to negative 14.
Anong negative? May negative bang oras?
Ay, hindi ba pala? Nakalimutan ko pa lang ano. Dito po, 2 seconds.
Ano?
2.08 raised to 10. Ay, 10 raised to 14. Malayo naman ang akin. Yung pilobas doon sa kanina pa eh.
Ako nga, pindutin ko nga sa calculate. Kuha nga akong calculate. O, ayan ha. It only proves na hindi kayo marunong pumindot sa calculate. Kasi simpleng shift solve, hindi nyo alam.